like I said, we're moving on to our third. Okay, guys, we're starting notes now, all right? Thank you. So, we're learning 4 transformations in this unit. We've already learned 2. Here comes number 3, rotations, all right? Note sheet 5, like I said, comes right after note sheet 4. And we're going to start. What are we missing? Okay. So go ahead and get 5 glued in, wherever you left off. All right, just the vocab. So let's go ahead and just do 5 and 6 right here. Yeah. All right. So there's 3 different types of rotations that we're going to talk about. We're going to talk about a 90-degree clockwise rotation, a 90-degree counterclockwise rotation, and a 180-degree rotation. So 3 different types. We're going to talk about points first, and then, of course, we're going to talk about triangles after that. So can someone help me out? What does clockwise mean? Theo, can you help me out?
It's like, yeah, when you go...
In a circular motion to the right?
Go to the left. Wait, that's the left, right? Yeah, to the left. When you
Good.
go circular motion to the left.
Good. So everyone take a look up at the clock on top at the very front of the board. Or if you're in a different position, you can take a look at the clock that's... Oh, that one is not moving anymore. Well, that's okay. Just take a look at the clock at the front of the classroom. See that little red hand? How it's moving to the right?
Yes.
It's on 11 right now, and it's taking 1 space to the right each time. That is clockwise. It's the direction that a clock turns. Pretty self-explanatory, right? So if we're starting, just so we can get a visual of what I'm talking about. Okay, here's my clock. If I'm moving to the right, that's clockwise.
Wait, are we supposed to be doing that?
No. This is just for me to visualize it for you. Okay? If we're going to the right, that is clockwise. If we're going to the left, that's going to be counterclockwise. Okay? All 3 hands of the clock move to the right. Okay? So something to keep in mind is when we're talking about circular motion, right? If we start down here and our hands turn like this, it looks like we're going to the left. But because we're doing circular motion, really, that's a movement to the right, okay? So it's a little bit hard for us to visualize what we're talking about. That's why we have, well, this nice little rotation helper, which is going to help us out, just like this. Here's how we're going to use this rotation helper. Go ahead and grab yours out real quick from your pocket. You should all have this inside your pocket right now. This rotation helper. So to use this rotation helper, you're going to start with start and the up arrow pointing up. That's right here. All right? And if you're asked to do a 90-degree clockwise rotation, you find where it says 90 degrees clockwise, which is this arrow right here, and you rotate your paper until that's on the top. Okay? So everyone's got this out in front of them right now. Make sure start is at the top. Okay? And then rotate your paper so that 90 degrees clockwise is now at the top. Right? So what we did here, as we can see, is we're turning to the right 1 little turn. That's a 90-degree clockwise rotation. Go ahead and go back to start. If we wanted to go 90 degrees counterclockwise, we have to rotate this until we see 90 degrees counterclockwise on the top. That will just be 1 turn to the left, like that. Once we actually get to the problems, this will hopefully make more sense. That's just a quick introduction as to how we're going to use this rotation helper. So, let's just get right into it. 90-degree clockwise rotation about the origin. When we say about the origin, go ahead and add this in here. We just mean around. Could someone real quick give me the definition of a center of rotation? If you need help, take a look at your vocab chart from a couple pages back. Let me get my rich tickets. Hold on. There's a term that we kind of skipped past a little bit called center of rotation. Hannah, you want to read that definition for us?
The anchor point that a figure rotates around.
One more time.
The anchor point that a figure rotates around.
Exactly. The anchor point in which a figure rotates around. All right? So line of reflection is kind of like the anchor line in which we flip a figure. The center of rotation is the anchor point in which we turn something. Okay? So, make a nice dark dot right there at your origin. Jocelyn? Sure. Make a dot right there at your origin. Our pre-image point M is right here at the coordinates of 2, 3, it looks like. 2, 3. And we're going to graph the image of point M after a 90-degree rotation clockwise about the origin. Luckily for us, we're only going to be rotating about or around the origin, so that's going to stay the same for whatever problem that we're doing. 6 steps. 6 very clear steps on what we need to do here. In order for us to get this done, go ahead and pass out your expo markers to each member of your group. Let's make sure everybody has an expo marker in their group. If you have an expo marker that does not work or something, I have extras that I can give you. I highly suggest with this lesson, if you're doing something on your Chromebook right now, just close it, all right? You're going to get confused if you're not with us, okay? So close your Chromebooks, please. You will be confused if you're not 100% focused on what we're doing, okay? I'm not explaining this twice. Well, I mean, I will, but anyway. Go ahead and put your transparent slide directly over your graph, just like that. Take your transparent slide, put it directly over the graph, just like that. You're going to take your expo marker, and you're going to draw a plus exactly where the origin is at. Boom, boom. You're going to draw a plus directly onto your slide using an expo marker, right where the origin is at. So we're going to take this step by step, all right? I want to come by and see that everyone is with me exactly where I'm at. Good. Raison, that looks good. Noah, that looks good. That looks good. So, again, we're taking the transparent slide, we're putting it directly over, and then we're drawing the plus, okay? We got to listen, folks. We got to listen. Talk to Miguel about what you guys did wrong. Good. Good. Great job. Yes. Yeah, keep that, yeah. Right over the origin. Good. Good, good, good. Okay. Now that we've drawn a plus right where the origin's at, that's going to keep us grounded. Making sure that our plus sign is directly in the center. As exact as you can make it. I know that the expo markers are a lot thicker. That's okay. That's all right. Don't worry about it. Just do it over on the slide too. Make it as close as possible. I know that the markers are thicker than the lines. Just keep it as accurate as possible. Okay, we did step 2. Now we're going to do step 3. Draw a dot where point M is. Directly over that point, draw that dot right there onto your slide. And then just off to the side, make sure you write M. This is going to make sure we know which direction our slide is facing upward. Okay? Let's go to step 4. We're going to rotate our slide to the right once. Again, moving to the right is clockwise. Here's what we're going to do. We're going to take our slide. We're going to keep it centered as best as we can. We're going to turn it one space over to the right until that plus matches right back up on our axes. I'm going to do it again. Here's where we start. We're going to turn over to the right, which is this direction, one space until that plus sign matches right back up with our axes. We'll do it one more time. Take a look. Here's where we start. We're going to the right 90 degrees, which is just one turn. Turning to the right, to the right, to the right, to the right, until that plus sign comes right back to where it needs to be. So step 5 is lining up the plus sign with the origin again. That's right there. And now we're going to place a new dot where M lines up. Now this part is a little bit tricky because we have to see where that point's going to be. And then we move our slide and make the point right there where it goes. So you can either hover your pencil directly above the point, or you can take a look and go, oh, I need to draw a point at 3, -2. Boom, that's where I draw my point. And what can we call this point? M prime, exactly. M prime has the coordinates of what? 3, -2. That's exactly right. 3, -2. What do we notice about this transformation that's different from the previous transformations that we talked about? Think about it for a moment. What's different about this? Look at the coordinates. Look at where our point ends up on the graph. Think about what we did, right? Go ahead and take 30 seconds, talk with your group mates real quick. Just outline any differences that you notice between what we worked with last week versus what we're doing right now. 30 seconds, go ahead, start.
I think that
She doesn't hear what I said?
All right, any ideas? Anybody want to share for a rich ticket what their group came up with in terms of differences here between what we did last week and what we're doing now? Jordan, go for it.
The two numbers are like splits.
Tell me more about that. What do you mean?
Where it's like 2 and 3, they're like they switch coordinates. Yeah, X and Y.
So the actual numbers used in our X and Y coordinates seems to have flipped. Here we had 2, 3. Now we have 3, -2. Interesting observation, Jordan. Thank you for that. Any other observations here? Well, I notice a difference here between reflections and rotations, right? Notice how with a reflection, our points were always symmetrically lined up across an axis, right? Now it's completely out of whack, right? This M point does not line up with M prime, and M prime is not the same distance away from our axis than M. So this is a completely different transformation when compared to a reflection. However, with this transparent slide, as you can see, it's really, really simple or really easy for us to visualize exactly what we're doing and then doing it. Now, without this transparent slide, imagine trying to get this rotation correct. Just imagining that point kind of turning, right? It'd be really hard for you to visualize that and get it to an exact point. That's why we have this slide, so that every single time we rotate it, we end up exactly where we need to be. Any questions about that before we move forward? Okay. Now, this next part, if that makes sense to us, should be pretty straightforward. Our pre-image point N is at 2, 3, same exact spot as M. We're going to go ahead and erase our slides here. If you need to get some paper towels or something, you could just use your sleeve or something, honestly. But if you need like a legit eraser, you can get some paper towels or a Kleenex real quick. We're going to be doing a lot of drawing and then erasing. All right? I don't want to recommend you guys ruining your clothes, but I would just wipe it off on my pants. But whatever works for you. Don't ruin your white hoodie or jacket or anything trying to erase. Just grab a paper towel at the front. All right. Let's go ahead and get this point rotated here. We're going to do the exact same thing, except now we're going 90 degrees counterclockwise. So we're going to be moving to the left. Okay, guys, stay with me. I know erasing slides is exciting, but stay with me here. We're once again going to put our slide over our graph. Okay, are there questions I can answer, folks? Jerry, you got a question? Okay, then there should not be talking right now. I don't know how many times I have to say it. So we're going to do exactly what we just did. Put a plus at the origin so we can line up our axis after the rotation. And we're going to draw a point right there where N is at, and we'll label it N. And my pen is dead. Boom, N is right there. Now, instead of moving to the right, we're going to rotate this to the left. Now, if this is still a little confusing, you can use your slide and your rotation helper together. Here's how we can do that, all right? We set up our plus and our N. We know that we need to go counterclockwise, which is to the left. So if we have our slide here, right, we want to rotate this until we see 90 degrees counterclockwise on top. We can take both of these and turn them like that. All right, 90 counterclockwise is on top. That's the rotation I did. Now we just have to line this plus back up, and boom. That's where our new point is going to go at -3, +2. And we can call that new point N prime. So here's where we started with our pre-image. We turned over once to the left, counterclockwise. And right there is where we end up. There's where we start. We turn one space to the left, line that plus back up, and there's N prime right there. Once again, take note of how our numbers flipped around, and one of our signs actually flipped around here too. Interesting. Okay. Questions about rotating 90 degrees? All right, we're all good. Let's flip over to our note sheet number 6 now. Now we're going to do our third type of rotation. We're going to do a 180 degree rotation. I'm trying to erase this slide.
I sat my leg.
All right. Here's how we're going to rotate 180 degrees now. We got point O, the pre-image of point O. is at negative 2 comma positive 4.
Excuse me, young boy. You pass me.
Okay, guys, what do I have to do to get you guys to stop talking for real?
I'm trying to get the.
Let's take a walk.
What?
Just, guys, get it together, please. I don't need the side conversations. I don't need the comments. I need you to focus on this. Point O is at negative 2 comma positive 4. Now we're going to go 180 degrees. It doesn't say we're going clockwise or counterclockwise. Does anyone know why that is? Noah?
Because 180 degrees is just in the middle of clockwise and counterclockwise.
Exactly. It doesn't matter whether you go 2 spaces to the left or 2 spaces to the right because you end up in the exact same place. Let me show you what I mean. Here's my rotation helper. Right? If I go 2 spaces to the left, 1, 2, I see that I went 180 degrees counterclockwise. If I go back to the beginning and I go 2 spaces to the right, 1, 2, I can see that I went 180 degrees counterclockwise. Right? It doesn't matter whether we turn it twice to the left or twice to the right because we end up in the same exact place. All right? So, let's put our slide over our graph. We'll draw a plus right at the origin and a dot right at our point O. Okay? Here's what I have on my slide. Right there. Right here in this little, really, really tiny font, you see it doesn't matter which direction. Just rotate your slide twice. Here we go. I'm going to go to the right. 1, 2. Line up my plus right where it goes. And I see now that my point O prime is at 2 comma negative 4. Right there. O prime, 2, negative 4. Now this one actually kind of does look like a reflection in some way. A diagonal reflection, exactly. If we had a line like this that we reflected across, that's exactly what it would look like. Or we could say that it's like a reflection across the y-axis and then another reflection across the x-axis. Yes? Yeah. So again, it doesn't matter whether we turn to the left or turn to the right. Let me show you. Here's where we start. If I went 2 to the left, 1, 2. Take a look at that. We end up exactly in the same spot as O prime. Quick show of thumbs. How's this sounding to you guys so far? Okay. Good. All right, enough of points. Points are easy. Let's rotate a figure. Okay, this is what we're actually going to be doing here. Rotating a figure. So think about the process that we just did. We put our slide over the graph. We drew a plus. We marked all our points. We turned it, lined that plus back up, and marked all of our new points. We're going to do the exact same thing here, just 3 times. Well, we only have to do the rotation part once, but we're making 3 dots. You guys get what I mean, okay? So go ahead and take 60 seconds real quick. Identify where points P, Q, and R are currently at. Okay, on the bottom of note sheet 6, go ahead and identify where P, Q, and R are at. P looks like it's at 1, 2. Q's at 4, 4. And R is at 4, 2. All right. We're going to graph the image of triangle PQR after a 90-degree clockwise rotation. Are we going to go to the right or to the left here? If we're going clockwise, are we going to go to the right or to the left?
Right.
To the right, right? Right. Okay? So, let's go ahead and get going. We're going to place our slide. I'm going to get a clean one. going to place our slide over the graph. Let me zoom in here. Okay, slide over the graph. Make a plus at the origin. And now I'm going to make 3 dots. One at P, one at Q, and one at R. But I'm not going to draw my lines. Why? Because we're not plotting lines, we're plotting points, right? So we don't need to draw the lines, we just need to draw the points. Now when we rotate a figure, things get all topsy-turvy, right? Whatever point was on the top is now no longer on the top. So especially with triangles, we want to make sure that we're labeling at least 2 of the points. I just label all 3 of them so that we know where our prime points end up and we're not mislabeling them after the rotation. 90 degrees to the right, or 90 degrees clockwise. If I start right here, I go 1 turn to the right. Hey, look, there's 90 degrees clockwise. So we're going to go 1 turn to the right. Boom. There's where my new triangle is going to land. So P prime looks like it's at 2, -1. And you can just keep sliding it back on and back off to get where your points are at. 2, -4. That's R prime. And then 4, -4. That'll be Q prime.
But aren't we supposed to do it 3 times?
No.
No, this is what I meant. We're going to do that 1 dot 3 times because we have 1, 2, 3 dots. Sorry, that's what I meant by 3 times. That's the full rotation right there. So like I said, if you have this slide at your disposal, at your disposal, things are a lot easier. So do not lose this slide, please. You only get this one. All right? New coordinates for P, Q, and R. Can someone help me out for a rich ticket? Where's P prime's coordinates at? Alexa? 2, -1. Thank you very much. Olamipo, did you have Q primes?
4, -4.
4, -4 for Q prime. Exactly right. 4, -4. And then Andy, you got R prime? 2, -4. Thank you. Good. So, again, take a look at our points from beginning to end and see if you can notice a trend. Is there any rule that you can infer is going on here just based on where we started and where we ended up? Just take a moment to look. You can even talk with your group on anything that you notice for a second while I get these rich tickets passed out. Thank you. Thank you.
Oh, never mind. Yeah. Oh, counterclockwise.
All right. How do we feel? Show of thumbs real quick about rotating a figure. Thumbs up if we feel good. Thumbs sideways if we need to see some more examples. All right. Here comes note sheet number 7 to get glued in. And then we'll be done. This will be quick. This will be quick. We already know what we're doing now. We know how to use the 2 things. We'll be fine. You're welcome.
There's more.
There you go. There you go. There's 5. Max. Anybody not get note sheet 7? Yeah.
Here's the bathroom.
Yeah. Anyone not get 7? We're all gluing it in? Good.
I ain't reading all It's a lot of glue.
Have a good day, Max.
No, not today. Who's making that sound, bro?
All right. Let's take a look at note sheet 7. Let's get this done real quick so we have time to work. Oh, we're cutting it short on time, but that's all right. Here we go. Okay, whoever's making that noise, stop it.
He's making feral
Jesus.
final sound.
Okay, here we go. Triangle STU. S is at -3, 1. T is at -2, 5. U is at -1, 1. So now we're again going to rotate this 90 degrees, except now we're going to rotate it counterclockwise, 90 degrees. Is that going to be turning to the left or turning to the right? Turning to the left, right? Counterclockwise is to the left. So, get your slide over your graph. Draw your plus at the origin. STU. I'm only going to label S and T because I don't have really room to label U. And if I have 2 points labeled, then I can assume what the third point's going to be called, right? So we're going to turn this once to the left. Here we go. To the left, one time. Line that plus back up. Boom.
Ours is different.
Say that one more time.
Ours is different.
I need to.
Okay, hold on one sec. Okay, number 7 right here.
Thank you.
Oh, it's right here.
Oh, why they call it shoes?
So here's where we start. We turn it one space to the left. There's our 90-degree rotation right there. Just 1 point there. There's U prime, S prime, T prime. And there is my prime figure, or my image, as we learned last week. So it's really obvious when we have a triangle as opposed to when we rotate a point. We can clearly see that we turned this triangle 90 degrees to the left. It was pointed up, we flipped it over, now it's pointing to the left, right? It's a nice visual representation of exactly what we're doing when we rotate these triangles. Notice how we completely changed quadrants. We started out in quadrant 2. Our image is in quadrant 3. But we did not just simply flip it over the x-axis. If we did so, the triangle would be pointing downward, right? So let's take a look at our new points. S was at -3, 1. S prime is at -1, comma, -3. Interesting. T prime is at -5, -2. And U prime is at -1, -1. Hey guys, relax, it's okay. What did we lose? That's alright, we'll find it. Don't worry about it for now. So there's our 90-degree counterclockwise rotation. Now let's go ahead and close it out with a 180-degree rotation about the origin. Draw our plus at the origin, x, y, z. Again, we're doing the same exact thing. Starting out these problems is always the same. Now we just have to make sure we're going in the right direction and the right amount of times. Which direction are we going to go here? To the left or to the right? Does not matter. Thank you, fellas, for catching that. I'm going to go 2 to the right. Here's one rotation. Boom. That's 90 clockwise. Here's another 90 clockwise. Together, 90 and 90 make 180, that's right. So we line that plus right back up. There's z prime. There's x prime. And there's y prime. And it's even clearer with the triangles now that a 180-degree rotation is just a double reflection. We'll talk more about that in a couple days, but you can kind of see that if we flip this triangle over the y-axis and then over the x-axis, this is exactly where we would land or end up. I'm just going to fill in my coordinates here. It doesn't really matter because we're not talking about the rule yet. It's just for us to get an idea of what the rule might be like. But we'll talk about that tomorrow. All right, what questions can I answer about rotations? Show thumbs, how are we feeling about this? Thumbs up if you feel like, that was pretty straightforward. I understood that. I feel like I can do that on my own. Thumbs sideways if you're like, I understood it, it makes sense, but I'm a little cautious about doing it on my own. And thumbs down if it didn't really make that much sense and you might need a little extra help. I want to see everyone's thumbs real quick. So even if you're ignoring me and having a completely other conversation right now, go ahead and show me either a thumbs up, sideways, or down. Cool. Looks like we're in a good spot.